Hello guys, you're welcome to today's class. I want to believe you guys are doing very fine. This is Chemistry Hangout. If you are just watching this YouTube channel for the very first time, kindly subscribe to this channel. This is one of the best YouTube channel as far as chemistry content is concerned. And if you're already part of the Chemistry Hangout family, I want to welcome you chemically to today's teaching, and I want to believe you are going to learn a lot from today's class. Very quickly today, I want to talk about the other two chemical laws that I promised to actually, do. If you remember, I have uploaded chemical law, I've uploaded law of conservation of mass, I've uploaded law of definite proportion. And I made mention in the video that I'm going to do the other two laws so that we can understand how all these law govern reactant coming to product, or how this law governs reactant coming together before product will be achieved. This law governs chemistry, and it is important that we understand them. So I am here to talk about those two laws. I gave an assignment for the last one I did. I gave assignment of law of definite proportion. I want to appreciate the subscribers that took their time to actually do it and provide the answer in the comment box section. Well done, guys. Well done. It shows you are actually getting the teachings here. And if you have not done it, please, all these things are important for you to be able to build intensity and confidence in all those topics. So you are welcome once again. If you have not checked that video, go and check it so that you will not be, you will not be lost as per what we are doing on this channel. So I will start with the law of multiple proportion today. I'm going to start with the law of multiple proportion. Interesting law, fantastic law. Law of multiple proportion, and all these law are, they are chemistry basics. So law of multiple proportion, that's what we are going to talk about. Now, what's this law? What does this law state? What's the meaning of this law? Let's take what the law is, then I'll explain and I'll give examples of how to actually calculate law of multiple proportion. The law states that the law states that the law states that if the law states that if two elements A and B combine, the law states that if two elements A and B combine to form more than one compound, okay? I want to believe we are together. Form more than one compound. The several masses of A which combine, the several masses of A which, let me say, chemically combined. Very important, because it could be physical, okay? So let's say chemically combine, the several masses of A which chemically combine with a fixed mass of B, with a fixed mass of B is in simple ratio. Please, if you are going for JAMB, you are going for WAEC, please, you need to understand this law. You should be able to state them. Very important. The law states that if two elements A and B combine to form more than one compound, the several masses of A which chemically combine with a fixed mass of B is in simple ratio. What is this law saying? What is this law talking about? Let's take for example, I want to explain this. Let's take for example, I have copper I have copper, just an example, copper react with oxygen, just an example, copper reacting with oxygen to form copper 1 oxide, something like this, okay? And copper again react with oxygen to form copper 2 oxide. If you check here, the ratio of copper to oxygen on the first one, which is this, is around 2:1, and the ratio here is around 1:1. I want to believe this is clear. So if you look at this now, if you look at this copper, you will see the oxygen is fixed. Look at that. Oxygen is 1:1. So the oxygen is fixed. So the several masses of copper which combine with a fixed mass of oxygen here is in ratio what? 2:1. So they will always bear ratio 2:1. That's what that law is actually saying. So the several masses of A which combine with a fixed mass of B. So let's say copper is the A and oxygen is the B. Can you see? So the several masses of A which combine with a fixed mass of B. So we are assuming that B is fixed. Anyone can be fixed anyway. I'm still going to explain that when I'm doing the calculation. So A can be fixed, B can be fixed. It depends on the one you are comfortable with. So, but here I'm taking B to be fixed. So because B is ratio 1:1, so oxygen is fixed. So they are combined with, several masses of A, which is copper. They will be a simple ratio. And the simple ratio here is what? Is 2 to what? Is 2:1. So which means what the law is saying specifically is talking about ratio. So several masses of A which combine with a fixed mass of B could be in 1:2, could be in 2:1, could be in 2:3, could be in 3:4, depending on the element we are actually talking about. So very, very important. Understand that the law states that if two elements A and B combine to form more than one compound, the several masses of A which combine with the fixed mass of B are always in simple ratio. I want to believe this is clear. Are always in simple ratio. Are always in simple ratio. Let's take examples of questions under law of multiple proportion. Let me give this example. I'm still going to give another assignment like I used to do, just to test your hand on all those things if you really understand. So example, let me take example 1 now. Example 1, let me write example 1. So copper forms 2 oxides by reacting with oxygen to form copper 1 oxide. That's this. Okay, copper 1 oxide and copper 2 oxide. That's this. Okay, analysis. I told you, because we are not doing the practical, because all these things have their practical application, but since we are not doing the practical, they are now giving us the value. So in the analysis, they said in copper 1 oxide. So analysis is showing that in copper 1 oxide, okay, in copper 1 oxide, we have 11.00 gram of oxygen combining with 89. So in copper 1 oxide, let's say copper, let's say oxygen. So in copper 1 oxide, we have that 11.00 gram of oxygen, okay, and 89.00 gram of copper. Why in copper 2 oxide? They're giving us those values, very important. In copper 2 oxide, we have 20.00 gram of oxygen, then we have 80.00 gram of copper. Now look at this. Can you see the difference between law of definite or constant proportion and law of multiple proportion? In law of definite proportion, we would be needing the mass of the oxide, the mass of the element, and the oxygen. Let's say, for example, they are talking about maybe copper oxide, like the way they are doing now. In law of constant proportion, we are going to be needing the mass of this copper oxide itself. We are going to be needing this value. And we can get that, if you remember, we can add this together to get that. We can add this together. But in law of multiple proportion, we are only interested in the mass of the copper and oxygen. We are only interested in the mass of the element and the oxygen that is there. We don't really need the mass of the oxide, although we can get it, but we don't really need it. Okay, so these are the analysis they actually gave us. So how can I prove with this analysis that it obeys law of multiple proportion? Now look at it now. Look at what I will do now. So let's go now. In copper in copper 1 oxide, okay, in copper 1 oxide, we have that 89.00 gram of copper is reacting with what? 11.00 gram oxygen, like as they have given us here, this one they gave us here, 89 and 11. That's what I'm using. So 89.00 gram of copper is reacting with 11.00 gram of oxygen. I'm not going to fix either of the elements, either copper or oxygen, right? Because this is for copper, 89 is for copper, 11 is for oxygen. So for me, I am fixing copper now. I want to fix copper. I want copper to be fixed here. So I'm going to use any number that I want. So me, I'm using 1 gram. You can use 10, you can use 15, you can use any gram. You're still going to get the same thing. So if 89.00 gram of copper combined with 11.00 gram of oxygen, 1 gram of copper will give X of this. So I'm fixing this. That's where the law comes. Fixed now. I'm fixing that. So if I cross multiply, I'm going to have 1 times 11.00. So if I cross multiply, my X is going to be 1 times 11 divided by 89.00. So, and if I use my calculator, 1 times 11.00 divide 89 is giving me 0.1236 of oxygen. Don't forget that I fixed my copper, and this is my fixed copper. So you can use any number. My fixed copper here is 1. You can use any number of your choice. You can use 2, you can use 3. You're still going to get the same thing. So why in copper? Let's see in copper 2 oxide now. In copper 2 oxide, what do we have in copper 2 oxide? So we have that 80.00 gram of what? Of copper react with 20.00 gram of oxygen. Don't forget we have fixed the copper, so we are using the same value. Since we have fixed the copper to be 1 gram here, so we say 1 gram here also is going to give me X of this. So X is going to be 1 times 20.00 over 80.00. So let me use my calculator. If I use my calculator for that, I'm getting around is 0.25 gram of oxygen. I hope this is clear. 0.25 gram of oxygen. So what do we do now? Let's bring it side by side because law of multiple proportion is dealing with ratio. So in sample 1 now, in sample 1, I add 0.1236 gram, okay, into ratio. In sample 2, I have 0.25 gram. Okay, if I divide this one, which one is the smallest? This one, okay. So if I divide this one by itself, it's going to give me 1. Why if I divide 0.25 by 0.1236, it's going to give me what? 2. So which means that the meaning of this is that the several masses, the meaning of this is that the several masses of oxygen which combine with which combine with a fixed mass of what? Of copper. Don't forget we fixed copper is in ratio copper is in ratio 1:2. Correct. So and that's law of multiple proportion. They are in simple ratio. So the several masses of oxygen which combine with a fixed mass of copper is in the ratio 1:2. So this is correct. Law of multiple proportion, meaning we are getting ratio 1:2. So the several masses of A which combine with the fixed mass of B is a simple ratio 1:2. I want to believe this is clear. Let me do other example for people that are still finding it a bit difficult. Let me do example 2. So sometimes you have to go through all those things. You have to know that you are sitting for JAMB, you are sitting for WAEC. You need to know all this. Example 2. So let me take example 2 and let's work that one out too. Let me take example 2. Example 2 says that phosphorus phosphorus forms two oxides by reacting with what? With oxygen. Okay? By reacting with oxygen. Analysis of the two oxides shows that one 56 gram of phosphorus combined with 44 gram of oxygen. Okay, while in sample 2 it said 57 gram of phosphorus combined with 43 gram of oxygen. So if it is WAEC, they will ask you, show that this result illustrate a particular law. So you are the one that will show them. Why if it is in JAM, they can just say, show the ratio of which they combine. So if it is JAM, they can say, show the ratio of which they combine. If it is WAEC, they can say, use this result to illustrate a law in chemistry. So you need to just know how they ask that question. So let's have the solution now. Very simple. So I can say now in sample 1, what happened? I have 56 gram of phosphorus reacting with 44 gram of oxygen. So here now I'm fixing phosphorus now with any number of my choice. Don't forget the first one I used 1. Here I'm using 10 now, 10 gram. You can actually use any number you like. So from there our x is going to be 10 times 44 over 56. 10 times 44 over 56. Let me use my calculator. 10 times 44 divide 56. That's giving me 7.857 gram. Okay. Why in sample 2? In sample 2, they already gave us, they said 57 gram of phosphorus react with 43 gram of oxygen. Don't forget we have fixed phosphorus already and the fixed mass is 10 gram. Then it will be equal to S. Then X will be equal to what? From here, what will that be? That will be what? X will now be 10 times 43 divide 57. So our X will be, we use my calculator, 10 times 43 divide 57. That's giving me 7.544 gram of oxygen. I hope we are together. Okay, so let's see if they obey that very particular law. So the sample 1, the value was 7.857. into ratio, the sample 2 was 7.544. The smallest here is 7.544. So if we divide this by 7.544, it's going to give us 1. So ratio, if we divide 7.857 by 7.544, it's giving us 1.04 also, which is approximately to 1. So which means that this very particular 1 2 is in what? The ratio here. The ratio here is going to be 1:1. That's what. So, which means the several masses, the several masses of oxygen that react with fixed mass, fixed mass of phosphorus is in ratio 1:1. Correct. That's wonderful. That's correct. I want to believe you are clear now. I'm still going to give an assignment after this. After I've done the last law, I'm going to give an assignment for you to test your hand on so that you remember. If it is JAMB, they can ask you to look for the ratio. Okay, if it is JAMB, they can ask you to look for the ratio. If it is WAEC, they can give you those values and ask you to use it to prove a law. So you should be able to differentiate if it is law of definite or law of causality. They're not going to tell you the law. You should be able to know the difference between the two of them. When you see the values given that a substance form more than one compound, when you see that very particular thing, you should know. When a law is saying it form more than one compound, know that what they are talking about is law of multiple proportion. Yes, and form more than, when you see any, any question that comes in that form and form more than one compound, oh, just know the probability that it's going to be law of multiple proportion is what is very, very high, because your law of definite is not talking about forming more than one compound. Your law of definite proportion is telling us that if it is a pure sample, their chemical compound contain the same element, contain in the same proportion by mass. So law of definite proportion is telling you they are combined in same proportion by mass. Why? When you see form more than one compound, the probability that is going to be law of reciprocal, law of multiple proportion is high. So very quickly, that is that. You can try that. I'll give an assignment at the end of the class. So, but let me take the last one before we call it a day. Let me take the last one now, which is law of reciprocal. A lot of textbook omitted this very particular law because it is an interesting law because it governs how reactants react together to actually give us product. A lot of textbook just stated the law. Yeah, a lot of textbooks stated the law, but no calculation, no explicit explanation about it. Why some just did few calculations on them without a simplified explanation. So, but let's look at what the law of reciprocal, let's look at what the law of reciprocal is talking about. Let's take the law, then I will explain with around 2-3 examples, then I'll give you one at the end so that you can do it too. So what is the law? The law was postulated. Let me give a detailed note about it so that we'll understand. It was proposed. The law was proposed. The law was proposed by Jeremiah's Richter in 1972. Yeah, Richter in 1972. Yeah, it states that if two elements, wonderful and fantastic law, if two elements combine separately with a fixed mass, of the third, element, comma, the ratio of masses in which the ratio of masses in which they do so, in which they do so are either same as or simple multiple of the ratio of the masses in which they themselves combine with each other. Bit longer, but the explanation with each other. And that's why a lot of textbooks omitted it. Some just stated this law, and and that's all. And it is also called, let me not forget, it is also called law of equivalent proportion. That's another name for it. Equivalent proportion. Okay, so the law was proposed by Jeremiah Richard in 1972. It states that if two elements combine separately with a fixed mass of the third element, the ratio of masses in which they do so are either same as or simple multiple of the ratio of the masses in which they themselves combine with each other. A lot of people did not understand this very particular law. Okay, so let's break it down. Let's break it down. Now pay maximum attention to this. Let's break it down. If I have, let's break it down. Let's break it down. Let's break it down. Okay. If I have, let me have a triangle like this. Let me use this to explain. And I have element A, I have element C, and I have element B. I hope we are together. A is going to combine with C. Okay. A will combine with C to give us AC, right? A can combine with, A can combine with B, right? Yeah, A can combine with B to give us what? A, AB. While B can combine with C to give us BC. So in other words, I can say my AC is going to combine in ratio A to C. I hope we are together. My BC is going to combine in ratio B to C, right? And my AB is going to combine in ratio A to B. Now look at what the law is saying. Let's take this two case study first. If you look at this, your C is fixed now. Look at this. A reacted with C to give us AC. B reacted with C to give us BC. So your C here is fixed. So the law is now saying that if AB, which is the third, will react, they must do so with the simple ratio of this A here and this B. So the ratio of this A and this B will be the same with the ratio of this A and this B. I don't know if you are getting that. I will do an example so that you see. And that's what the law is saying. Very simple law. That's what the law is saying. Okay, let's have an example now. Let me now show us using some elements in the periodic table and trying to form some compounds now. Now look at this. Look at this. If I have something like this, okay. Then I have hydrogen here, I have carbon here, I have oxygen here. So let's say hydrogen reacts with carbon to give us methane, that's CH4. Okay, hydrogen reacts with what? With oxygen to give us H2O, and what? Carbon reacts with oxygen to give us what? CO2. Now let's look at this now. Your CH4 here is combining in ratio what? Carbon here is 12 and hydrogen is 1 times 4. That will give us 12 ratio 4. I hope we are following. While our CO2 here is going to be carbon is 12 into ratio, oxygen is 16 times 2, that will be 32. Now look at this. Your carbon is fixed already. Okay? So your carbon is fixed here already, which is 12 to 12. Carbon is fixed. So the law is now saying that for this H2O to rightly combine, they must combine in ratio 4 to 32. And 4 to 32 is still the same thing as, 4 here, 4 ratio 32 is still the same thing as saying 1 ratio 8. So what this law is saying is that If this combination is going to be right, if this combination here like this is going to be right, in as much as your carbon is fixed here, carbon reacted with hydrogen, carbon reacted with oxygen, so carbon is fixed already, 12 to 12, which means if this hydrogen and this oxygen is going to react like this third one is doing, it has to be in 1:8. So let's see if it is true. So let's come to H2O here now, this H2O that is here, let's see their ratio. So H2O ratio is going to be what? 1 times 2, that will be 2 to ratio. Oxygen here is 16. If I still break this down, it's going to give me 1:8. Can you see that? Correct. Correct. That's what the law. So the law of reciprocal is law of equivalence, meaning the ratio here in this combination will be the same with the ratio here in this combination, which makes this very chemical reaction or equation very, very correct. And that's what law of reciprocal is all about. I know some people are still getting it confused. Let me do another one. Let me show you another one. Very interesting law. In fact, I love that law than any other law in those chemical combination. I really love that law because it's not common and it's showing the way reactants really react to actually give us product. Okay, look at this one. Let me do another one. Then I can now give an assignment for you to work on so that the video will not be too long. Okay, look at this. I have hydrogen here, okay. I have phosphorus here, okay, and I have chlorine here. So hydrogen reacts with phosphorus to give us this. Are we together? Hydrogen reacts with chlorine to give us HCl. Hydrogen reacts with chlorine to give us PCl3. Okay, let's see their ratio now. For pH3, don't forget that your atomic mass of phosphorus is going to be 31 into ratio what? Into ratio 1 times 3. For hydrogen is 1 times 3, that will be 3. This is sorted. Then our PCl3 2. Phosphorus again is 31 into ratio. Our chlorine is 35.5, right? Times 3, that's going to give us 106.5. Did you notice something here? That your phosphorus is now fixed. Can you see that? It's now fixed. Which means that this hydrogen and chlorine that want to react, they must react in this 3 to 106.5 ratio before it would be accepted. So we can still break further. Let's break this down. 3 into 106.5. 3 here, 3, that's 1. In 106.5, it's going to give us 3. 106.5 divided 3 will give us 35.5. So which means if this combination will be correct, which means hydrogen reacting with chlorine, they must react in ratio 1 to ratio 35.5. Let's see if it is correct with the combination. HCl that is formed. What is hydrogen? That's 1, right? What is chlorine? 35.5. Can you see that? Correct. Correct. And that is what the law of reciprocal is talking about. That's why it's called law of equivalence. In fact, this is a very interesting law, and that is how it is formed. I know a lot of people might still be finding it a bit difficult, but you need to try it. I'll give an example for you to try it on and put the answer in the comment box section. So that, but you need to go over it over and over again, especially people that are not familiar with this law of reciprocal. Just look at what the law is. This is what the law is talking about, and I've given examples. So you need to watch it over and over again for you to actually understand. Okay. So for my chemistry educators, for my co-chemistry educators, you can work with these and develop a lot of examples yourself. But for Jambite YX students, you hardly get law of reciprocal in exam. You hardly get it. You hardly. I've not seen it. I've not seen it from experience. I've not seen them asking you question on law of reciprocal. So, but you just need to know it is one of those laws. But for core chemistry educators, you just need to know all those things to extend our knowledge and for us to learn together and grow together. And that is that for this law. So let me give 2 assignments for us to work on as students. I'll give one on law of multiple proportion and I'll give another one on law of reciprocal. So let me give this for law of multiple proportion. So you can just do it and you can provide the answer in the comment box section. Let me see if you get it. Let form 2 oxides by reacting with oxygen. Analysis So just do this yourselves to build confidence. Analysis of the two oxides shows that shows that in oxide oxide 1, 86.6 gram of lead combines with 13.4 gram of oxygen, while in the second oxide 92.8 gram of lead combines with 7.2 gram of oxygen. Okay, show that this result illustrates law of multiple proportion. So if it is JAMB, they can just try to get the ratio. Okay, if it is YN, they can tell you to, the question can come like this. So pay maximum attention. Assignment 2, do this yourself. That will be on law of reciprocal. The assignment 2 will be on law of reciprocal. So let me just give you a diagram. Just prove it yourself and see if it is true. So you have a diagram like this. Okay, I have hydrogen here, I have sulfur here, I have oxygen here. Okay, so this one, hydrogen will be reacting with oxygen to give us H2O here. Here is giving us H2S, and here is what? SO2. So use this illustration to prove love. So use it to prove law of reciprocal proportion. And that is that. Okay. So that is that. You can use this. It's a very simple assignment. You can just use that, just try it on your own. I've told you, you are going for JAMB, you are going for WAEC, they might not be asking law of reciprocal. Okay, but you can just try it on your own just to add to your knowledge. But for core chemistry educators, you actually need this, to be able to, add to your knowledge, and you can actually teach students if you want it, probably an advanced chemistry class. And that is that. So that is that for today's class. I want to believe law of multiple proportion, well explained, well understood. If you have not, if you don't actually get it, you can watch the video over and over and over and over again. So you can just check this. Sometimes if you need to write all these things, you can just rewind the video and just go back and so that you can just get the note from the beginning, from where we started. You can just get the note from actually where we started. Okay, so if you are new to this channel, you can see this is one of the best chemistry channel you can find on YouTube. So kindly subscribe to this channel, turn on your notification bell. There are more videos that are loading, a lot of videos for JAMBite, for WAEC students. You are doing JAMB, IGMB, WAEC, JUPEP, a lot of videos is going to drop this year. It's going to be a wonderful year, and we are here back this year to give you nothing but the best. For chemistry teachers, WAEC is fast approaching. You are still finding some kind of, preparing reagents. You are still finding it a bit difficult. You can always chat me up. I'm going to drop a link in the comment box section. You can chat me up so that I can see how I can help as regards to that. Please practice this thing. You are sitting for JAM. Very important, law of definite proportion and multiple proportion are likely questions you're going to get. If you are doing YL2, like question, you're going to get law of multiple proportion, law of definite proportion. But for core teachers, you need to know all these things so that it will extend our knowledge. So that will be all for today. So we have done law of conservation of mass, law of definite proportion, law of multiple proportion, and law of reciprocal proportion. So till we meet again on this channel, if you have not clicked that subscribe button, kindly click it and turn on the notification bell so that you would be notified when I drop any video. Thank you so very much. I love you guys. Bye. Bye.